I'm Jordan Boyd Graber, and today we're introducing INST 808. The official title of this class is Quantitative Methods. Each person who teaches it has a different spin on the course. In this iteration, we're going to be focusing on deep learning and statistical analysis, particularly on text data. This class uses a flipped classroom. That means I will be recording lectures like this and posting them on YouTube. Most of them will be new, others will be reused from previous classes. On average, there will be a video each weekday of about 15 minutes. We'll also have a weekly discussion on Zoom. It looks like that will be Mondays at 9:30 a.m. Eastern. The next video talks more about how that will work, but it was created in pre-corona times. Everything still applies except for the face-to-face bit, but I hope I can still meet many of you face-to-face when it's safe. And for those of you watching on YouTube that aren't officially in the class, welcome to you too. My philosophy is that a professor's obligation is to not just educate students enrolled in a class, but to benefit the public as a whole, particularly at a public university like the University of Maryland. I've always done this. Take a look at my library of other videos, but in Corona times, I'm going to try to be a little bit more deliberate about this, releasing new videos about one per day so that people can follow along at home if they want. Those not officially enrolled in the class won't be able to join the discussion sessions, but you will be able to submit questions, for example, leaving a comment below, and you'll be able to access all of the assignments and slides from the course webpage, link in the doobly-doo. But anyhow, enough about logistics. What is this course actually about? The sexy answer that you'll want to put on your job applications is deep learning, but our goal is to give you the tools that you can use to understand information in a scientific way, whatever technique you use. This is an information science course after all, so we'll be teaching you how to draw conclusions from data using several tools, the most complicated of which is deep learning, but we're going to cover lots of other things. Professors like to talk about learning outcomes. What will you be able to do after you finish this course? Well, you'll be able to take information and run it through a computer program. You'll be able to use tools like regression to discover relationships between variables in a data set. You'll be able to use statistical tests to tell whether two things are different. And you'll be able to use visualization tools to tell a story about your data. And you'll be able to create deep learning models to make predictions and annotations automatically on text data. We'll focus on text in this course, but the lesson should transfer to other applications, whether you're working on social networks, images, or cell phone data. And along the way, you'll probably become a better programmer in Python. Now, you might be scared by all this. This is not a computer science course. So we're going to take things a little more slowly and not go as deep into the implementation and the details. We'll review key programming principles in math, but we won't be able to cover everything. For the math, you should be able to follow along with basic algebra, even if you don't get all of the details. And we're doing a review next week of the essential math. For programming, we won't teach you how to program in Python. I'll assume that you can either catch up to where you need to be without too much hand-holding, or that you can transfer knowledge from some other programming language that you know. That said, we'll be using toolkits that do most of the work for you. So you mostly need to know how to edit and run a Python program and how to move data in and out of a Python program's components. But you don't need to do much from scratch. So why should an information science student take a course like this? Here are the cool things that you'll be able to do after finishing this class. Take all the tweets from a presidential debate. What are people talking about? This is using topic models. Which of these documents are about women's rights and which are not? This is a classification task. Which of these sentences mention the name of an Indian author and which do not? This is a problem of named entity recognition. How do you translate this document from German into English automatically? That's machine translation. We'll talk about the fundamentals that you would need to implement each of these methods, or at least to be able to use a toolkit that does that for you. And beyond that, we'll discuss how to present these methods in a research context, creating attractive figures to explain a data set, using statistical tests to tell whether two data sets or models are different, running a regression to find relationships between variables, and explaining that in a scientific context like a paper. During the course, we'll touch on how these concepts and ideas connect to many different fields that fall under the umbrella of information science. While we'll be focusing on the big picture, these tools are the foundation of cutting-edge research in machine learning, the subject of my own research. And hopefully I'll be able to share a little bit of that along the way as well. So in conclusion, welcome. I'm really looking forward to this class. It'll be new and exciting for a variety of reasons, and I hope to go on a fun journey with all of you. If you want to see more videos like this, check the video description for the course that comes from the link down below. You can then see the context and the correct order for watching these videos. YouTube will gleefully show you stuff in the wrong order. If you want other people to see this video, provide a big gradient to the recommendation algorithm by clicking the like and subscribe button down below.